Hello everyone, welcome to my channel CIC Topper Classes. Today we are going to discuss chapter 6 Factorization, exercise 6, question number 8 to 18. So let us start solving this exercise here in this video. If you like this video, don't forget to like, share and subscribe my channel. Now let us solve question number 8. Using the remainder theorem, find the remainders obtained when x cube plus kx plus 8 into x plus k is divided by x plus 1 and x minus 2. Hence we have to find here k if the sum of two remainders is 1. So here we can write as remainder we have to find when it is divided by x plus 1. So f of minus 1 by remainder theorem we can write that will be the remainder without division. Here we are using remainder theorem, so it will become minus 1 ka whole cube plus k into minus 1 plus 8 and again minus 1 plus k. So it will become minus 1 here, then again minus k plus 8 into minus 1 plus k. Again here on multiplying it will become minus 1 plus k minus 8 plus k. So again 2k minus 9 is the remainder by dividing with x plus 1. And if we divide by x minus 2, f of 2 will be the remainder. So 2 ka whole cube plus kx will become 2k. So 2k plus 8 into 2 plus k. So that will become 8 plus 4k plus 16 plus k as 5k plus 24. So as this is the value here, we can write find k if the sum of two remainders is 1. So f of minus 1 plus f of 2 is equal to 1. Then we will put the value to find the value of k from here. So 2k minus 9 plus 5k plus 24 is equal to 1. So that will become as 7k, and 24 minus 9 will become 15 plus 15 equal to 1, where say 7k is equal to 1 minus 15 and k is equal to minus 14 by 7. This will be cancelled out and we will get minus 2 as the final answer here. So this is the solution of question number 8 and this is the way to solve it. Let us solve question number 9 here. By factor theorem, we have to show that x plus 3 and 2x minus 1 are factors of this. So we can write, if we put f of minus 3 in the equation here, then it should be 0. So if you put it will become 2 into minus 3 ka whole square plus 5 into minus 3 and then minus 3. So on solving it will become 2 into 9 here minus 15 and minus 3. 18 minus 18, so it will become 0. Hence it is proved from here that by factor theorem x plus 3 is the factor here. It is proved that x plus 3 is a factor of fx, which we have let here as fx. Now if we write again the second part, that is f of 1 by 2, we have to write that it is a factor, so it is also should be equal to 0. So 2 into minus 1 by 2 ka whole square plus 5 into minus 1 by 2 here, sorry 1 by 2 only, it is not minus 1 by 2, 1 by 2, and then minus 3. Taking square here, 2 into 1 by 4 plus 5 into 1 by 2 minus 3. This will be cancelled out and we will get 1 by 2 plus 5 by 2 minus 3 as 6 by 2 minus 3, and 6 minus 6 by 2 will become as 0. Hence this is also proved that 2x minus 1 is a factor of 2x square plus 5x minus 3 here. So this is also proved and this is also proved, and this is the solution of final solution of question number 9. Let us solve question number 10. Without actual division, we have to prove that this much equation is exactly divisible by x square plus 2x minus 3. So if we have to prove that it is exactly divisible, means this is a factor here. So firstly we will factorize this and form some a plus b form, ax plus b form equation, so that we can find the factors. So factorizing this equation, firstly we can write it as x square plus 3x, or we can write 2x only, 3x minus x we can write, so minus 3. Taking x as common, it will become x plus 3, and minus 1 as common, x plus 3, from where we can write x minus 1 into x plus 3 is the factors of this equation. And now by putting in this fx equation, we have to find that it is the factor of this equation or not. So by simply applying factor theorem, we can prove here also, in this part also, that these are the factors here. So firstly, for by factor theorem, if we put for x minus 1, so if we write for factor theorem x equal to 1 here, that will become f of 1 is equal to 1 की power 4 plus 2 into 1 whole cube minus 2 into 1 का square plus 2 into 1 minus 3. That will become 1 plus 2 minus 2 plus 2 minus 3. This will be cancel out, and from there we can write 4, or sorry, 2 plus 2 and minus 2 again. So or 3 minus 3, this will be also cancel out, means x minus 1 is a factor of this equation fx. Now polynomial fx, and now if we write for x is equal to minus 3, we will put f of minus 3 here. That will become minus 3 की power 4 plus 2 into minus 3 का whole cube minus 2 into minus 3 का whole square plus 2 into minus 3 and then minus 3. That will become 9 into 9, that is 81. So 81 minus 27, and 27 into 2, that will become 54 here. Hence minus 54, then minus 9 into 2 will become 18, then again minus 3 into 2, 6 minus 3. Solving this part, it will become 81 minus 54. Firstly, we will add this part. So 81 minus 54 minus 18 minus 9, and adding this part, it will become 81 minus 72 minus 9 here, because minus minus will be added and we will get 81 minus 9, again it will be added, so that will become as 81 only, minus 81. Hence this will be cancel out, means x plus 3 is also a factor. So from there we can write x plus 3 and x minus 1 are factors of this equation polynomial fx. If this is divisible here, fx is divisible by x plus 3 and x minus 1, from there we can write x plus 3, fx will be divisible. Fx is divisible by x plus 3 and x minus 1. Hence we can write, if it is divisible by x plus 3 and x minus 5, then fx is exactly divisible by gx also, which is, this is the gx form, fx plus 3 into fx minus 1. So x plus 3 into x minus 1 will form that polynomial gx here, which we have let here. So this is the polynomial gx we can write, and this is the final solution of question number 10. Now let us solve question number 11. We have to show that x minus 2 is a factor of this equation, hence factorize this. So let fx here is 3x square minus x minus 10. If it is a factor, this is, we have to prove that it is a factor. So f of 2 should be equal to 0 for proving that. So if we put f of 2 in this equation, that will become 2 ka whole square minus 2 minus 10. So 4 into 3, 12 minus 12, this will be cancel out and we will get 0. Now we have to factorize this equation here. So for factorizing, we will divide 3x square minus x minus 10 divided by x minus 2. So we will factorize here, that will become as, in multiplying by x, we will multiply it with 3x. So that will become 3x square here minus 6x. So solving it, this will be cancel out if we subtract here, and here it will be become positive, and 6x minus x will become 5x, and this is 5x minus 10. Now again we will multiply it with 5x, 5 only. So plus 5 we are going to multiply 5x, then minus 10. Hence this will be cancel out here, means remainder is 0 only, as we have proved firstly. So this is also cancel out, means 0. From there we can write, if we factorize, we are getting the quotient as 3x plus 1. So fx we can write it as 3x square minus x minus 10 as equal to x minus 2. The uh, dividend here in multiplied by 3x plus 5. That is 3x plus 5. So this is on factorizing we are getting. So this is the final answer and final solution of question number 11. Now let us solve question number 12. Using the factor theorem, we have to show that x minus 2 is a factor of this equation. Hence factorize the polynomial completely, it is written. So we can write, if we have to factorize it, firstly we will divide this part with x minus 2. So x is equal to 2, from there we can write. So factorizing the polynomial, so here fx we are letting it as x cube plus x square minus 4x minus 4. By factor theorem, we have to prove x minus 2 is factor. So if we put x is equal to 2 in this fx equation, that should be equal to 0. So by factor theorem, we will put, so it will become as f of 2, 2 ka whole cube plus 2 ka whole square minus 4 into 2 and minus 4. That will become 8 plus 4 minus 8 minus 4. So this will be cancelled out. This will be, we are getting 0. Hence proved that x minus 2 is a factor of this fx here. And then we have to factorize now the polynomial completely. Factorizing the polynomial here, we will get here as x minus 2 and factorizing, and this is x cube plus x square minus 4x minus 4. So we will multiply with x square first of all. So this will become x cube, then minus 2x square. Subtracting that part, this will be cancelled out and we will get 3x square this side. Now minus 4x. Again multiplying with 3x here. So multiplying with 3x, that will become 3x square minus 6x, and subtracting that part, this will be cancelled out and we will get 2x here. 2x minus 4. Again multiplying with 2, that will become plus 2, and 2x minus 4. This will be cancel out whole thing and we will get 0. From there we can get on factorizing fx, this polynomial, as x cube plus x square minus 4x minus 4, because remainder is 0. Hence this gx into fx we can write. So x minus 2, the dividend and quotient, x square plus 3x plus 2. So this is the final answer here in this question. And this is the solution of question number 12. We have factorized the polynomial here. Here we can factorize it in most simple form as x minus 2 here by quadratic equation x square plus 2x plus x plus 2 here. That will become as x minus 2, x square taking common x plus 2, and then 1 is taking common again x plus 2 here. That will become x minus 2, x plus 2 into x plus 1 here. So this is the simplest form here on multiplying the divisor with the quotient, making it its simplest form. Hence, this is the final solution of question number 12. Now, let us solve question number 13. We have to show that 2x plus 7 is a factor of 2x cube plus 5x square minus 11x minus 14. Hence, we have to factorize the given expression completely using in factor theorem. So, we can write it as 2x plus 7 is a factor of this. So, from there, if we have to prove by factor theorem, we can write x is equal to minus 7 by 2, and fx, if we put as minus 7 by 2 to prove that it is equal to 0 in the equation, that will become minus 7 by 2 ka whole cube plus 5 into minus 7 by 2 ka whole square minus 11, then minus 7 by 2 and minus 14. That will become 2 into, this is 343 here, and that will become 16, or sorry 8 here, and on negative value we have to take that. Now 5 into 49 by 4 plus 77 by 2 minus 14. So that will become 1 by 4 and minus 343 by 4 plus 5 into 49 here, 245 by 4 plus 77 by 2 minus 14. Taking LCM, we will take 4 as LCM, minus 343 plus 245 plus 77 into 2 here. On taking LCM, so it will become 154, then minus 14 into 4. So this will become 56 here. Now we will solve these things. Here it will become minus 98. Now 154 minus 56, that will become 98 plus 98 divided by 4. On cancelling, we will get 0. Hence it is proved that 2x plus 7 is a factor of fx, is a factor of fx here. Hence from there we can write. And if we have to, second thing we have to show that this is only we have to show, and now we have to factorize the given expression by 2x plus 7 only. So we will divide that 2x plus 7 divided by this equation here, which is 2x cube plus 5x square minus 11x minus 14. Firstly we'll multiply it with x square, so that will become x square 2x cube plus 7 into x square, so 7x square this side. Subtracting, this will be cancelled out, and here we will get minus 2x square minus 11x. Again on multiplying with x, so that will become on multiplying with x here, we will multiply with minus x now, so that will become minus 2x square, then minus 7x, and adding it here, this will be cancelled out, and here we will get 4x, minus 4x. So here minus 4x, minus 14, and again multiplying with 2x here, that will become minus 4x, and this will be minus 14 here. Oh, sorry, only 2 we will multiply. So here minus 14. Now this will be cancelled out, this will be cancelled out, so remainder is 0. And factorizing this again, we will get as 2x cube plus 5x square minus 11x minus 14. This is the fx here, and subtracting it, it will become 2x plus 7 into x square minus x minus 2, and that is 2x plus 7. Here x square minus x minus minus 2x and plus x minus 2 here. Factorizing this, 2x plus 7 quadratic equation as x taking common x minus 2 plus 1, then again x minus 2, that will become 2x plus 7, and here x plus 1 and x minus 2. So this is the answer on factorizing, and this is the final solution of question number 13 here. Now let us solve question number 14. Here we have to use the factor theorem to factorize the following polynomials. So here we can put in place of x as minus 1, means x plus 1 we are going to take the factor here. So we know if f of minus 1 we put in this fx there, we can write by factor theorem that that should be equal to 0. Then only x plus 1 is the factor of this polynomial fx. So it will become minus 1 ka whole cube plus 2 into minus 1 ka whole square minus 5 into minus 1 and minus 6. So it will become minus 1 plus 2 plus 5 minus 6. That will become as 7 minus 7, and as it is cancelled out, we can write from here that x plus 1 is a factor of fx polynomial here. Now in this question it is given we have to factorize the polynomial completely by this factor only. So x plus 1 here divided by this polynomial x cube plus 2x square minus 5x minus 6. So we can put here x square firstly on there. So x cube plus x square here. This will be subtracted and it will be cancelled out. We will get x square minus 5x. Then again we will multiply with x. So plus x, then x square plus x. This will be cancelled out and we will get minus 6x minus 6. Again we will multiply with minus 6. So it will become minus 6, and here minus 6x minus 6. Again it will be cancelled out here. Means the remainder is 0, and on factorizing here, we can write the polynomial fx here x cube plus 2x square in the form of factors as x plus 1 into the division into the quotient x square plus x minus 6. We will factorize it with quadratic equation. On factorizing, it will become x square plus 3x minus 2x minus 6. So it will become x plus 1, taking x as common, x plus 3 minus 2 as common, again x plus 3. From there we can write x plus 1, x minus 2 and x plus 3 are the factors in this equation. This is the answer, and this is the final solution of question number 14, first part. Let us solve this question here. If we write, this is by using factor theorem, we can write x is equal to minus 1 here. So if we put x is equal to minus 1, means f minus 1 should be equal to 0. That will become minus 1 ka whole cube minus 13 into minus 1 minus 12. So here minus 1 plus 13 minus 12, it will become minus 13 and plus 13. This will be cancelled out and we will get 0. As it is 0, we can just make that it is the factor by factor theorem and factorize this polynomial. So x plus 1, x cube minus 13x minus 12. We will multiply with x square here. That will become x cube, and here we can write x square plus x square. This will be cancelled out, and here we can write x square minus x square and minus 13x. Then this only we can write and then multiply by minus x. So it will become minus x square minus x again it will be cancelled out, and we will get minus 12x here, then minus 12. Again multiplying with positive value of 12, we can write here plus 12. Oh, sorry, minus 12. It will become minus 12x, then minus 12, and this will be cancelled out. From there, fx is x cube minus 13x minus 12, and this is x plus 1 into x square minus x minus 12, and that will become, on factorizing, x plus 1 x square minus 4x plus 3x minus 12, and x plus 1, taking x as common, x minus 4 plus 3 as common, x minus 4. Then we can write x plus 1, x plus 3, and x minus 4 is the factorizing of polynomial. And this is the answer in this question, and this is the solution of question number 14, second part. Now let us solve question number 15. Use remainder theorem to factorize the following polynomial completely. If we want to use the remainder theorem, we know we can put x is equal to 2, then it will be 0, and then from that we can write that that is the factor, and then we will factorize the polynomial. So we know if we put let x is equal to 2, that will become as 2 into 2 ka whole cube plus 2 ka square minus 13 into 2 plus 6. That will become 8 into 2, that is 16, plus 4 minus 26 plus 6. Then 20 minus 20 is 0. And as we know, x minus 2 is a factor of fx, that is 2x cube plus x square minus 13x plus 6. And now from that we can write, if it is the factor of fx here, then that will become, on factorizing, as 2x cube plus x square minus 13x plus 6, and dividing with x minus 2, that is 2x here, it will become 2x square minus 4x here. So this will be, or we can write a square here, so it will become cube, cancelling this part, and here is square. And here if we add, that will become 5x square minus 13x, multiplying with 5x here, that will become 5x square minus 10x. This will be again cancel out, and we will get minus 3x plus 6. Multiplying with 3 here, that will become positive, negative of 3, sorry. So negative of 3, it will be minus 3x minus 6, and this will be cancel out. Sorry, plus 6 it will become. So on adding, it will be cancel out, and remainder is 0. From that we can write factorization of this polynomial here, 2x cube plus x square minus 13x plus 6 is division into quotient. X minus 2, 2x square plus 5x minus 3. That will become x minus 2, then 2x square plus 6x minus x minus 3, and that will become x minus 2, taking 2x as common, it will become x plus 3 minus 1 as common, again x plus 3, and we will get x minus 2, then 2x minus 1, and x plus 3. So this is the uh, factors here of this polynomial, and this is the final answer and solution of question number 15, first part. Let us solve question number 15, second part. If we solve this part here, on solving, we know we have to factorize it. So firstly, by factor theorem and remainder theorem, we can find the factor here. So we know if we put x is equal to 2, that is equal to 0. Whole equation is becoming 0. Fx is, so 3 into 2 ka cube plus 2 into 2 ka whole square minus 19 into 2 plus 6. It will become as 24 plus 8 minus 38 plus 6. That will become 24 plus 8 and minus 38. This will be cancel out whole thing. And if it is cancel out, we can write x minus 2 is a factor of fx here. From that we can write, on for solving the polynomial fx, 3x cube plus 2x square minus 19x plus 6. So solving this part and putting the value f of, because x minus 2 is a factor, so we will just divide this polynomial here. That will become x minus 2, 3x cube plus 2x square minus 19x plus 6. Multiplying with x square, firstly 3x square, that will become 3x cube minus 6x square, and solving this, it will become, this will be cancel out, and we will get 8x square minus 19x. Again here 8x multiplying, this will become 8x square minus 16x. Again it will be cancel out, and we will get 16 plus 19 here as 35x. That will be 35x here, and 35x plus 6. So multiplying with 35 here, sorry, this is subtracting here, hence it will become as minus 3x. So minus 3x plus 6 and minus on multiplying with minus 3, that will become minus 3x and minus 6 plus 6, sorry, and it will be cancel out, then it will be cancel out here, and we will get remainder as 0. Factorizing this, it will become fx will become on factorizing x minus 2 into the quotient 3x square plus 8x minus 3, and it will become x minus 2, then 3x square plus 8x minus 3, 3x square plus 9x, so plus 9x here, and minus x minus 3, and factorizing it by quadratic equation x minus 2, taking 3x as common, it will become x plus 3, minus 1 is common, again x plus 3, so we can write x minus 2, then 3x minus 1 and x plus 3 are the factors of this equation, and this is the solution of question number 15, second part here. Let us solve question number 15, third part here. We know this is the part we can put 2 in place of x. So f of 2 we have to find firstly. If we write f of 2, 2 into 2 ka whole cube plus 3 into 2 ka whole square minus 9 into 2 and minus 10. So it will become 8 into 2 16 plus 4 into 3 12 minus 18 and minus 10. Adding this part, it will become 28 minus 28. This will be cancelled out and we are getting 0. So x minus 2 is the factor of fx here. From that, if it is a factor, we will factorize the polynomial completely here. 2x cube plus 3x square minus 9x minus 10 by x minus 2 here. Multiplying with 2x square, it will become 2x cube minus 4x square. This will be completely cancelled out, and here 7x square minus 9x. Again multiplying with 7x plus 7x, that will become 7x square minus 14x. This will be again cancel out, and we will get 14 minus 9 will be 5x minus 10. Multiplying with plus 5, that will become 5x minus 10. This will be cancel out simply, and we will get the value of fx on factorizing completely x minus 2, and it is forming a quadratic equation 2x square plus 7x plus 5. Hence we will just make it solve. That will become x minus 2 and 2x square. 5 into 2 is 10, hence 5x plus 2x are the factors here, and that will become x minus 2. On taking factors here, 2x is common, that will become x plus 5 plus 2 is common, again x plus plus, sorry, we have to here take common as x only, so it will become x minus 2. Taking x as common, it will become, taking x as common, 2x plus 5, and again 1 is common, again 2x plus 5. So if we write, that will become x minus 2, x plus 1 and 2x plus 5 are the factors of this polynomial fx, and this is the solution of question number 15, third part. Let's solve this question. If we solve this question, firstly we have to find the factor of this equation. If we put f of 2 here, that will become 2 ka whole cube plus 10 into 2 ka whole square minus 37 into 2 plus 26. So it will become 8 plus 40 minus 4 here, and this will be 74 plus 26. Adding this, it will become 48 plus 26 minus 74. 4 here and 74 minus 74. So on cancelling, we are getting 0 as the answer here. We know if it is 0 means x minus 2 is factor of fx. So we will factorize the fx with this factor here completely. It is said in the question. So on factorizing, x cube plus 10x square minus 37x plus 26. So that will become, multiplying with x square, it will become x cube minus 2x square. This will be cancel out. Here on adding, that will become 12x square minus 37x, and multiplying with 12x plus 12x, it will become 12x square minus 12 into 2 will be 24x. So on subtracting, we will get 37 minus 24 will be 6 plus 7, 13x. So minus 13x plus 26, and again multiplying with minus 13x here, minus 13, it will become minus 13x plus 26, and it will be cancel out, and this will be cancel out, so 0. from there we can write fx on multiplying x minus 2 into x square plus 12x minus 13. That will become as x minus 2 x square plus 13x, or sorry, 12x into 13x minus x minus 13. So we can write x minus 2, taking x as common, it will become x plus 13, and um, minus 1 is common, again x plus 13 from there. On factorizing x minus 2, completely factorizing, we got the factors as x plus 13 and x minus 1. So this is the final answer of this question on solving, and this is the final solution of question number 15, fourth part. Now let us solve question number 16. If 2x plus 1 is a factor of this equation, then we have to find the value of a. If we write here factor x is equal to minus 1 by 2, so if we put f of minus 1 by 2 here, that should be the factor here, if it is the factor here. So if it is a factor, then f of minus 1 by 2 will be equal to 0. On putting the value of minus 1 by 2 in the fx here, 6 into minus 1 by 2 ka whole cube plus 5 into minus 1 by 2 ka whole square plus a into minus 1 by 2 and minus 2 here. That will become as 6 into minus 8 and then 5 into 1 by 4 minus a by 2 minus 2. So solving 3 by 4, it is cancel out, minus 3 by 4 plus 5 by 4 minus a by 2 and minus 2. On solving here, we will get 2 by 4 minus a by 2 and minus 2. This will be cancel out, and 1 by 2 on taking LCM we will get. Taking LCM, it will become minus a this side and minus 4 this side. So my minus a and minus 3 divided by 2 is the remainder here we are getting. And if it is equal to 0, we can find the value of a from here. So a is equal to 0 plus 3, and from there a is minus 3. A is equal to minus 3. This is the answer of question number 16, where the value of a we have to find, which is equal to minus 3 on comparing with the remainder theorem. We have applied here by remainder theorem, we have finded the remainder here because it is factor, and if something is factor, then the remainder will be 0, and hence it is the solution of question number 16. Now let us solve question number 17. If 3x minus 2 is a factor of this, we have to find the value of k. So if it is the factor of this value, then if we want to find the value of k, then firstly we can write the factor as x is equal to 2 by 3, and if we put f 2 by 3 here, that should be equal to 0. So 3 into 2 by 3 ka whole cube minus k into 2 by 3 ka whole square plus 21 into 2 by 3 minus 10. So here we can write 3 into 8 by 27 minus k into 4 by 9 plus 42 by 3 minus 10. So this will be cancelled out by 9, 8 by 9 minus 4k by 9 plus 1, it will be cancelled out by 1 and 4. So 14 minus 10. From there on subtracting, we will get 4. So 8 by 9 minus 4k by 9 plus 4. And taking LCM as 9, it will become 8 minus 4k plus 9 into 4 is 36. Adding 36 plus 8, it will become as 44 minus 4k divided by 9. As we know, the remainder is 0 because it is a factor. So f of 2 by 3 is 0. We will put the value of f of 2 by 3, that is 44 minus 4k by 9, and from there we can find the value of k. So that will become as 4k is equal to 44 minus 4k is equal to 0, and from that minus 4k is equal to minus 44. Cancelling this part, it will be cancelled out by 11, and k is equal to 11. From that we can write. So this is the answer of question number 17, and this is the solution of question number 17 here. Let's solve question number 18. If x minus 2 is a factor of this value, then we have to find the value of p here. If it is a factor, so if we put f of 2, that will be equal to 0. F of 2 we will find in the polynomial. If we put value 2 here in place of x, so that will be 2 ka whole square, then minus p into 2 minus 2. That will become 16 minus 4 minus 2p and minus 2. So 16 minus 2 will be 14, and 14 minus 4 minus 2p. 14 minus 4, 10 minus 2p. And if 10 minus 2p we will compare with 0, then we can find the value of p, which we have to find in the first part of question number 18. So minus 2p is minus 10, and this will be cancelled out. P is equal to 5. From there we will get. So the value of p is 5, and the second part is asked in the question. With this value of p, we have to factorize the above expression completely. So it is written with this value of p, we have to factorize the given expression completely. So if we have to factorize the given equation by p is equal to 5, we can simply write the value p is equal to 5, putting in the this factor here. So x minus 2 is a factor, so x minus 2, and putting here it will become 2x cube minus x square minus 5x minus 2. So multiplying with 2x here, 2x square, sorry, it will become 2x cube minus 4x square, and this will be cancel out. Here we will get 3x square minus 5x. So on solving, we will multiply with plus 3x. So 3x square here again minus 6x, and this will be also cancel out. We will get x here, x minus 2 plus 1 x minus 2, and this will be cancel out completely where remainder is 0. So from there we can write, if we want to write the factors of this polynomial, 2x cube minus x square minus px minus 2, that will be division into quotient. So x minus 2 into 2x square plus 3x plus 1, and forming factors, it will become x minus 2, 2x square plus 2x plus x plus 1 here. Taking common here as in quadratic equation like, so it will become 2x as common, x plus 1 here, plus 1 as common, again x plus 1. From that we can write x minus 2 into 2x plus 1 into x plus 1 is the factors here in this question, and this is the answer of question number 18 second part, final solution of question number 18 first and second part. Thank you for watching my video. If you like this video, please like, share and subscribe my channel.